here is how you handle things like this. You put brackets in. If I do that, I shouldn't use black. If I do that, that, and that, all of a sudden this comes pretty easy. What could you do if you just had that?
You just do basic subtraction of exponents, right?
No.
So what?
No. No. There's no like terms there. You would GCF it. You would take out what? X squared. And you would have x squared and 3x, right? Minus y. Agreed? Okay. What would you do here? 2x squared y, correct? No, not 2x squared, clowns. 2xy. And what would you be left with? 3x minus y. And what would you do here? Y squared. And what would you be left with? Now what do you see there, and there? A common factor. So that common factor would go to the front. And what would be left in here? X squared plus 2xy plus y squared. And you might think you were done, wouldn't you? But I would check, aren't there factors of 1 that add to 2?
Yes.
What are they?
1.
1 and 1. So 3x minus y, x plus y, x plus y, x squared, 1xy, 2xy plus y squared. And that, of course, you could also write, if you wanted to, as 3x minus y, x plus y squared. Everybody cool? I didn't expect many people to figure that out. I was just kind of hoping, right? Because if you see the numbers, you can kind of figure it out. Now that you know what the trick, what could you do here? Where would you put your first set of brackets there, Gideon?
X squared to 2x.
You'd put brackets there?
Wait, let me look at that. Actually, no, those are all in... No, you put it around the 1.
Yeah, you would, because that is x plus 1 squared, isn't it?
Yes, it is.
Right? Minus y squared. And now what do you see?
They're both...
Squared minus squared, right? So I take the square root of the first one, which is what? X plus 1 plus the square root of the second one, which is, and then
X plus 1 minus 1.
done. Picking up what I'm putting down?
Yes.
Read my mail, mowing my lawn?
No.
The third one is going to trick you. You now know the trick. Where would you put your brackets? I know where every single one of you is going to put your brackets. So I'm going to just wait and see who's going to offer some bracket ideas here. Roman?
A squared plus 12b minus 36.
Shut up, Roman. You did it right. None of you would have done that because that's a difference of squares, and 12b and 36 have a common factor.
I mean...
Of course some of you would have. But what you should have done was what Roman said, put them there, because then you get a squared minus b minus 6 squared, right? Or sorry. B, oh, wait a minute. Oh, did I write that wrong?
This looks like a question we have.
That looks like I wrote that wrong.
Which one?
Yo.
Is it like that one?
Yeah. Yeah, but that one needs... I got the negatives backwards there. That's embarrassing. Let me check my original document.
Well, I couldn't.
Right. But that's where your bracket needs to go. Because now what will you do with this? Take it out, right? And I get b squared minus 12b plus 36, yeah? And then that's a squared minus b minus 6 squared, yes? And isn't that squared minus squared? So I get a plus b minus 6 and a minus b minus 6. Picking up what I'm putting down? Please notice that we're not doing anything new to simplify that, are we? It's just putting more than one thing together. Now, would I put something like that on your test? Something like these three? No, I'd put that on as a bonus, right? That's the thing that takes your test from a 3 proficient to a 4 extended. Picking up what I'm putting down? In the future, it's all recorded, sister. Huh?
But you don't call girls other words other than women or
I don't call them chicks or babes or anything like that. I honestly believe that we are all related. Because if you go back far enough, there's only two. No. 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 There is... All of humanity came from one very small area in Africa. All of us. And it's very interesting. If you go to that small area of Africa and you look at the people that still live there, you will see... No, just stop. Every time you say something, I say no. You should just rein it in a little. They are all, yes, indeed, darker skinned, but some of them are as black as the ace of spades, and some of them are barely darker than me. Some of them look like very tanned Asian folk. Some of them look like very pardon me? Not quite that pale. But you can see all the characteristics of current humanity in that very tiny piece of Africa. Which is why it boggles my mind that people still insist that we didn't evolve. No! Every religion has is creationist. My God, man! You're an Never mind. Yeah, that's true too. Something like 39% of all human males share a particular genetic marker because Genghis Khan sired millions of children. Actually, no. He sired thousands of children, but 15 generations ago.
And it's like there's like I can't remember the number in
It's a crazy number.
Asia who's related to him.
So, Andre, since we all came from one spot way back when, we are all indeed, no matter what Mr. Trump says, related. if you go back far enough. So, calling, I don't even remember who I was talking to, Aditi, my sister. It's just a figure of speech, but in actuality contains a grain of truth. Okay? And yes, thank you, Gideon. I do my best to speak as wisely as I possibly can. Even sometimes when I have to translate using charades. All right. Let us move it along, cabbages. I left you with page 81. Let's start. Thomas, number 1.
X plus 7, X minus 7.
Nicely done, Thomas. Is this allowed?
Yes.
Of course. So nobody ask. Number 2, Andre, hit me.
3x minus 5y, 3x plus 5y.
Oh, Andre, you're on fire, brother. See?
Brother.
Number 3, Benji, you weren't here yesterday. I'm letting you off the hook. Oh, you got it?
Yeah.
Well, hit me.
2x minus 5 and bracket x plus 5.
Yeah, you know it. No need to say the brackets, ladies and gentlemen. I know where they go. And number 4, Lockhart McGregor. Yes, I have an answer.
Andre, put your pants on.
Lockhart, number 4.
So first you'll do x squared plus 1, x squared minus 1, and then, but you can continue and finish with x squared plus 1, x plus 1, x minus 1.
Jayden, number 5.
X minus 12, X plus 5.
Plus 5.
Minus 5.
There you go. First try. Number 6, Gerline. 7, Mackenzie.
3 times x squared minus 16 and then x squared plus 16. So that can go down to 3 times x plus 4 and then x minus 4.
Beautifully done. 8, Hazen. What Mackenzie said.
That's right.
She's got it, buddy. She just doesn't have confidence in herself. Even though if she expands what she had, she would know if she did it right and wouldn't need to ask if she did it right. Go. Absolutely correct. Number 9. Patricia, you weren't here yesterday, but do you know it? Try it. What's the worst that can happen? I'll say no. Number 9. You did it absolutely correctly. Wonderfully done. Number 10, Alyssa. I would just put the 1/3 first. Nice. Number 11, Gideon.
Number 11, that's the one I didn't finish. Like, actually.
Okay. X plus 5, X plus 1. x minus 5, x plus 1. 12, Mia? Your mouth's full, of course. You don't want to speak while your mouth is full. I'll let you do 13 when it's your turn. Roman, 12. Yeah, Mia's just... x plus 3, x plus 3. Would I allow you to write this? Of course I would. Of course it's the same thing. Right, Aditi? Yeah, it is. You want to do 13 there? Oh, Gideon, I'll give Gideon a chance because Mia's mouth's still full.
X to the fourth plus 4, x to the x squared plus 2, x squared plus minus 2.
Look at this guy. Why didn't he do anything more there? I can see a squared and a minus. Because 2 doesn't have a square root. Stop it. You kids. You're brilliant. Mm-hmm. Yes. Yes, indeed. Yeah? All right. This right here is A. This right here is B. This right here is C. Have I showed you this?
Remember this, Roman?
Something like this, maybe.
Okay. Up until today, we have never had a number in the spot of A that we couldn't get rid of. Here is what I mean. 3x squared plus 21x plus 36. You don't like that 3, so you divide everything by 3, and you get 3x squared plus 7x plus 12, and then we factor that 3x plus 3, x plus 4, right? That's all we've done up to now. We have not dealt with this not equaling 1 and not being able to get rid of it. Is everybody cool? Okay. Just to remind you, how do we solve that? That is x squared plus 10x plus 24. Yes? And we factor that by multiplying to 24 and adding to 10. Agreed? Okay. So is this in factored form or expanded form right now? That is in factored form because I have one thing times another thing, yes? So if we expanded it, we would of course have 6x squared, yes? Plus x minus 2. Everyone agree? Now, what we are going to do is today you are going to learn how to get from here back to here. All right? There are, of which I know, 4 methods to do it. Okay? One of them I don't like at your level because it's guessing. It's guess and check. All right? And it's okay. It kind of works. It works better when you're really good at this and you can start to see it. So I'm going to spend a minute showing it to you. So it's very simple. The first method is guess and check, which is the method that we really should start everything with, right? It's always good to have an idea of where you're going. Now, you're intelligent young kids. I have to multiply that to get A, don't I? And I have to multiply that to get C, don't I? You all know that, right? So, doesn't it make sense that to break this down, I need to have 2 numbers, I need 2 factors of A and 2 of C, right? Okay, so pretend we don't know the right answer. Pretend this is all you have. What are 2 factors of 6? 2 and 3 or 6 and 1, right? Those are your only options, yeah? And what are the factors of 2? 2 and 1, right? So all we do is we guess and we check. It might be 2x, and it's got to be negative 2, right? Right? Yeah. So it might be 2x minus 2 and 3x plus 1, maybe. And then I check. 2x, 6x, 2 times 1, negative 2. Okay. 2x minus 6x. Oh, that's not 1. So is this right? No. So then I say, okay, maybe it's 2x plus 2 and 3x minus 1. Check that. 6x, good. End works. Negative 2x plus 6x. Oh, that's not right either. Okay. So maybe it's, and you see what I'm doing? Charlotte.
Won't it be 6x squared minus x minus 2?
Oh, yeah, thanks. Sorry. Minus x. But we're still, these ones aren't working still, right? So that one didn't work. So maybe it's 2x plus 1, 3x minus 2, 2x times negative 2, okay. And then 4x, negative 4x plus 3x. Oh, there's our right answer. Does everybody see how it works? Okay. I don't like it, and here's why. What if this were 18 and this was 24? 1 and 18, 2 and 9, 3 and 6 for the first choice, yes? 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Many, many choices, yes? So I don't dig this too much. Later on, when you get really good at this, you'll start to understand the patterns a little better, okay? It will always work. You'll eventually get the right answer, but it's kind of persnickety. Everybody cool? All right. But it will work. Now let me show you 3 other methods. The first method is called decomposition. This is the way I was taught to do this. I used to teach kids this. Kids hated it. They couldn't make it work. They were like, what are you talking about? So then I spent a long time trying to find other methods to do this. I found other methods. I taught them to kids, and they're like, ah. And then I found a third method. Ah. And then, ironically, I went back to this method, and they were all like, oh, that makes so much sense. You people are alien to me. So I'm just now show all 3 other methods. You decide.
Single replacement and synthesis. Get it? It's a science joke.
Oh, you stop it. What?
Under guess and check, what did you write on the second line?
2 factors of A and 2 of C. All right. So in decomposition, now listen. In decomposition, if there is no number there, we got to multiply to 24 in regular factoring, yes? Right? But now there's a number there. How many times bigger is that than that? 6 times bigger. So doesn't it make sense that instead of multiplying to 24, I got to multiply to a number 6 times bigger? Right? So in decomposition, we got to multiply to A times C, which in this case is negative 12. Yeah? Right? But we add to negative 1 still. Because, remember in guess and check, it was the middle that was screwing us up. Right? In all of these ones that were wrong, the ends were working. Yeah? Okay. So what are the factors of 12 that add to negative 1? We already know what they are. What are they?
Negative 1.
Is it 1 and 12? Is it 2 and 6? Is it 3 and 4?
Yes.
Of course it is. 3 minus 4 is 1. Yes, negative 1, right? So, it is called decomposition because once we decide that it is 3 minus 4, we decompose the middle number. So we write 6x squared minus 4x plus 3x minus 2. And you can see that that is my negative 1. Is everybody cool? All right. Now, just like in our warm-up today, we then put brackets. What is the GCF here? 2x, right? So now I have 2x, 3x minus 2, correct? What is the GCF here? 1. 3x minus 2. Now notice, what do you see there and there? They're both common factors, so it's 3x minus 2 and 2x plus 1, which we know is the correct answer. Does everybody see how decomposition works? Okay. If you like it, use it. There's 2 other methods. The second method, and this is what I use. It is called, it has a fun name. I hate names like this. Slide and divide. Lame. Starts the same way. A times C, which equals negative 12, and add to B, which equals negative 1. And we know it's 3 and 4, right? So we do x squared, not x squared, x plus 3 and x minus 4. Now, how did we know to use 3 and 4? We knew that because we needed to multiply to 12, right? How did we know to multiply to 12? Because we did A times C, right? So the only reason we know it's 3 and 4 is because we multiplied by 12, right? Or by 6. So we got to get rid of that multiplication now, right? This isn't really 3 and 4 because it's only 3 and 4 because we multiplied by 6. So we got to divide by 6 now. Everybody cool? Everybody cool? Do you all understand why you're going to divide by 6? Okay. It's all right. Again, if there is no number out there, we're going to multiply to 24, aren't we? When there's a number out there, this is 6 times bigger, yes? So this has to be 6 times bigger, yes? Once we multiply by 6, that is what lets us know it's 3 and 4, right? Because we don't know it's 3 and 4 until we know we have to multiply to 12. Are you good? Holy, okay. Can you do this? So I have to multiply to 24, right? Do you all understand that this 6 is 6 times bigger than that 1? Okay. So if this is 6 times bigger, I must be looking to multiply to something that is 6 times bigger. Are you good there? Yeah. So I multiply this by 6 because this is 6 times bigger. Are you cool? Okay. Once I have this as 12, then I know that that's what I need to multiply to. Right? And I know it's going to be 3 and 4 because I still have to get negative 1. Are you good there? Okay. Now, why did you know that it was 12? Because you multiplied by 6, correct? So I have to get rid of that multiplication here. So I have to divide it out because we're factoring. When you factor, you have to divide somewhere, don't you? How do you know what the factors of 12 are? By dividing, yes? So I have to divide here. Are you good? Okay. Would you ever leave that fraction for Mrs. Bad Crumble? What is that? 1 over 2. Would you ever leave that fraction for Mrs. Bad Crumble? What is it? 2 over 3. Now, what you have here is x plus 1/2 and x minus 2/3, correct? Don't write that down. That's what we have, right? What there bothers you? Just say fractions. It's the fractions that bother you. You're all scared to death of fractions. I already know this. You're not surprising me. The fractions bother you, yes? How do you get rid of a divided by 2? You multiply by 2. The 2's will cancel, but that 2 has to distribute there, doesn't it? 2x plus 1. 2x plus 1. What do you have to do there? Cancel, but the 3 distributes, right? 3x minus 2. That's why it works. Why is it called? It should be called divide and slide, really. Why is it called divide and slide? What did we do with these denominators that were left over? We slide them to the front. 2x plus 1, 3x minus 2. That's divide and slide. If you like it, keep it. Now, there's a third way. This is my personal least favorite way. But some kids find it very useful, so I show it to them. It doesn't have a name of which I know, but it starts the same way. A times C to equal negative 12, add to B, which is negative 1, right? So in this one, instead of doing x and x, we keep the 6. 6x plus 3 and 6x minus 4. Everybody cool? Now, the reason I don't like this is because of the step we're about to do. Would you ever leave that binomial in my class? Why not? It's got a GCF of what? 3. Agreed? Would you ever leave that binomial in my class? Because it's got a GCF of what? 2. Now, normally when we do GCF, we can't forget about it, can we? It has to move to the front, yes? In this instance, in this method, we do forget about it. That's why I don't like this method. Because this is a time that we forget about the GCF. What is this when I divide it down? 2x plus 1. What is this when I divide it down? 3x minus 2. And you see that you get the same answer no matter which method you use, including guess and check. Is everybody cool? Now, you've only seen the methods once each. It is a little early to make a decision on what you like, yes? So I am going to do rando methods here. Alright? Okay. So, I'm going to do guess and check here. Alright? Everybody okay with that? So, I just need to pick any two numbers that multiply to 20. Now, how often has it been 20 and 1? How often has that been our choice? Not very. How often has it been the next one, like 2 and 10? A little bit, but still not very. It's often the middle ones, isn't it? So what's the middle here? 4 and 5. So my first guess is 4 and 5, which would be B and B, obviously, right? 4 times 5, yeah. And 10. What is it? 1 and 10 or 2 and 5, right? Which one do you want to try? 2 and 5, because it's almost never 1 and 10, is it? So everything's plus, so plus 2, plus 5. Let's check. What's 4 times 5?
4 times 5 is 20.
20b squared. What's 4 times 5 here? 20. And what's 2 times 5?
10.
Is 20 and 10 33? No, so we're wrong. Okay, what if we do this? Plus 5 and plus 2. What's 4 times 5? 20. What's 4 times 2? What's 5 times 5?
25.
Is 8 and 25 33?
Yes.
There's our answer. Everybody understand? It took 2 tries, and we were wrong the first time, weren't we? In either of the other 3 methods, did we ever have to guess? No, we always knew the right answer all the way through, right? But they take a long time. In guess and check, there's a chance you get it the very first try. Hatisha.
So for like the test or anything, would we have to show all the guesses we took?
No. Everybody cool? All right, so let's look at number 2. 3 other methods. What one do you want to see? Decomposition? Okay. So we'll do decomp here. So, in decomposition, we have to break that guy down. That's what we are decomposing. If there was no 1 here, or if this was 1, we would know how to do it, right? But it's 3, so I got to do times 3. So what do I need to multiply to? What kind of 30? Negative 30. And what do I have to add to? Negative 13. Now you're all going to say 10 and 3, but of course it's not. What is it? 6 and 5 doesn't make 13.
13 is 1 and 32.
15 and 2. Thanks, Jayton. How will 15 and 2 get me to negative 13? Which of those is the negative? The 2 or the 15. So you've given me both choices. Which is the negative?
No.
The 2.
There was a song in the 80s called Opposites Attract, and one of the lines in it was, you take 2 steps forward, 1 step back. Picking up what I'm putting down? Negative 15. Because negative 15 plus 2 is negative 13, right? So, we decompose negative 13 into negative 15 and 2. Now, some kids like, which one goes first? It doesn't matter. Okay? So, we rewrite 3s squared plus 2, yeah? Minus 2s minus 15s minus 10. Yeah? Then I factor. What's coming out of here? S. S to the front, 3s plus 2. What's coming out of here? 5, right? 5? Do I want a negative at the beginning? So what's coming out? Negative 5. And what's this? Negative divided by a negative? 3s. And negative 2 divided by negative 10 divided by negative 5? Positive 2. And what do you see there and there? They're the same. So I get 3s plus 2 times s minus 5. Did I do it right? Did I do it right? Check. What's 3 times s? 3s squared. What's negative 15 plus 2? Negative 13. What's 2 times negative 5? Negative 10. If you're a decomposition fan, stinky. If you're a decomposition fan, can you do it? Can you do decomposition? If you want to use that forever and ever and ever, like the girl in iCarly, can you? Yes. Will I ever force you to use a different method? No. Okay. Now, for number 3, divide and slide, or the no-name method? You know I'm going to do the other one next anyway, so it doesn't matter. So we'll do divide and slide here. All right? But, dun, 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 what should I do first? GCF. Because why, Gideon?
All of those have a factor of 3.
You're damn skippy they have a factor of 3. So I got 3, 2x squared minus 7x plus 3. Oh, doggy. Now I'm dealing with this. And if we're going to slide and divide, what do I multiply to? So I multiply to 6, and I add to what? Negative 7. What is it? 6 and 1. Both negative, right?
Yes.
Of course. So I slide and divide. X minus 1 over what? 2, because I multiplied by 2 at the beginning, so I got to get rid of that multiply now. And x minus 6 over what? 2, because I multiplied by 2 at the beginning, so I divide by 2 at the end. Is that simplified? So what do I do with the denominator? I've done my divide. It's time to? I would multiply by 2. What is the result? The denominator slides. So I got 3, 2x minus 1. Would you ever leave that in Mrs. Backrumble's class? What is it? 3 over 1. Do I slide 1? No, because it would be 1x. We don't do that. X minus 3. And then we check. Is 2 times x 2x squared? Is 2 times negative 3 negative 6? Is negative 1 times 1 negative 1? Is negative 6 and negative 1 negative 7? Is negative 1 times negative 3 positive 3? Yes. Is 3 times 2 6? Is 3 times negative 7 21? Is 3 times 3 9? So did we do it right? So do you ever need to ask? Will that stop you from asking? No, of course not. You will still ask every single question. Mr. Myers, did I do it right? Everybody good? All right. If you're a slide and divide fan, or again, it should be divide and slide. All right. So now we go to no-name one, the President's Choice version. Ironically, no name is now a brand name, right? So, anyway, the no-name one starts the same. Multiply to what? Negative 40. And add to what? What is it? Negative 20 and positive 2. Yes? So, 8p minus 20, 8p plus 2. What do I do here? Naturally, you want to GCF that. Unnaturally, what are we going to do about that GCF? Forget about it. So what is the GCF there? 4. 2p minus 5. Yeah? What is the GCF there? 2. 4p minus 1. Is 2p times 4p 8p squared? Is negative 2 plus 1. Yeah. Is positive 2 minus 20 negative 18? Is 5 times 1 5? Yes. So did we do it right? Everyone is good? You've seen all 4 methods now. Okay. Let's look at 5. What you gonna do, kid? No. Before you decide on your factoring method, you need to GCF. Why, Mackenzie? Because you GCF whenever you can, just like it's written right here in giant green letters. So what's the GCF? Now, this is a natural GCF situation. So do we get to forget about 4? No. 4. 6h squared minus 5h minus 6. Yeah? Now make your decision. Guess and check, decomp, divide and slide, or no name. You decide, attempt it. You decide on your method. Talk to your neighbor if you wish. The first method somebody says to me is what I'm going to do. Slide and divide it is. I will wait for everybody to do their attempt and for somebody to offer me an answer. I didn't get your quiz score yesterday, did I? Oh, yeah, I did. I walked around. Shayla, you've thrown your arm in the air. Wave it like you just don't care. What do you need?
I have an answer.
Hit me with that answer, sister. Wait. Okay, go.
4 brackets 2h plus 1 brackets 3h minus 6.
Oh. Shayla, you're killing me. What'd you say again? No. Again, I was waving my arms. I'm not sure if it was right. I didn't write it down.
4 brackets 2h plus 1 brackets 3h minus 6.
2h plus 1 and 3h minus 6. So, check that. I'm in highlighter mode. 2h plus 1 and 3h minus 6, yeah? What's 2 times 3? Right? So you're right there. And 1 times 6 is negative 6. So you're right there. But that is negative 12 plus 3. Oh. You're right on everything but your last 2 numbers.
The first time I did it, I got it right. And then I erased it and tried again.
There is the answer. Because 2 times 3 is 6. 3 times 2 is negative 6. Positive 4 minus 9 is negative 5. Now, please notice how, and this is a real word, so don't mock me, how persnickety this kind of factoring is. Right? You have to pay very close attention to detail. Yes? Because this doesn't work if the 3 is over here and the 2 is over here, does it?
No. Wait. No.
It doesn't work if the negatives are reversed. The negative and the positive, does it? You have to be careful. Everybody good? Now you will notice I did slide and divide, so I ended up with 9 and 6 and 4 and 6, which I of course simplified to 3 and 2 and 2 and 3, and then I slid the denominators. But of course, sliding the denominators is just the result of doing the math that you want to do to get rid of the denominators, isn't it? Right? Right? Okay. What should we do for 6? No name? All right. So in no name, I still do times 2. Multiply to 6. I lie like an idiot. Multiply to 12 and add to 13. What is it? 12 and 1. 2n plus 1, 2n plus 12. GCF, naturally or unnaturally? Unnaturally, because we're going to forget about it. What is the first GCF? 1. So it stays the same. 2n plus 1. What is the second GCF? 2. So I get n plus 6. And then I check. 2n times n, is that 2n squared? You're darn tootin'. 2n times 6, is that 12n? Plus 1 times n, is that 13n's? Yep, and 1 times 6 is 6. No name method. Worked lovely. Yeah, yeah? Yeah, yeah, yeah. Everybody cool? You guys work until... Well, you guys do 7 and 8. Method of your choice. Go. Go diddly-o. Everybody loves math. It's their favorite class. They all wish they could go to math because they kick its ass. Math is so much fun. If I would marry it because it is the one. Without math, I am lost. Without math, I can't think of anything to rhyme with lost. Without math, my mind feels tossed. Tossed upon the sea, I cannot be. Because you're listening to my bad freestyle? I cannot be truly free. There we go. Wow, I'm Eminem. Literally, my initials are Matt Myers. M-M. M-N-M. Yeah, and I'm older than him, so he stole it from me. M-N-M. Because his name is Marshall Mathers. M and M. Eminem. Why do you think he did that? That's not true. My rap name was MC Mars because my middle initial is C. I was MC Myers. No, just Mars sounded like Myers.
That's not all you have to do.
I did decomp and divide and slide. Whatever method you did, you should have come up with the same answers. Yeah? Yeah. Yeah, yeah? Yeah, yeah, yeah. When I say factor, you say yeah. Factor.
Yeah.
See? Everybody gets it. I know not everybody gets it. But this is only your 8th practice at this. How many of you master something on the 8th time you do it? None of you. I want to make sure we do number 9 together. And then after number 9, you should be good by yourself. May we do 9? Yes.
So you know how you did 3t plus 6t and then over 3t on the other side, right? And then on the other side, are we supposed to do 3t also?
No, because you're taking the GCF of that and the GCF of that. If you're going to do decomposition.
Oh,
Everyone is good? All right. Let us have a look at 9. 9 differs in only one thing. What is it? It's to the 4th. You're intelligent young people. When it was 3x squared at the front, your answer was 3x and x, right? Because x to the 1 and x to the 1 gets me x squared. So logically, what is the only difference here? My first answer is going to be something t squared and something t squared. That's the only difference, right? Even though it looks different, you already knew how to do it. So, what method do we want there? No name? All right. So no name times 9. Multiply to what? 36. Add to what? 12. What is it? 6 and 6. So I have 9t squared plus 6 and 9t squared plus 6. In no-name method, do I actually keep the GCF? No. Divide by, what's my GCF? What's my GCF? So I get 3t squared plus 2 and 3t squared plus 2. And I'm done. Because 3 times 3 is 9, 2 times 2 is 4, 3 times 2 is 6, 2 times 3 is 6, 6 and 6 is 12. Yes? Is everybody good? Gravy, booby. What? Well, then what would it be, Lalam? 3. What if it was to the power of 8? What if it was the power of 26? What if it was to the power of 52? Then you couldn't do it unless you could GCF. 26. Yeah? So the question Hatisha asked was, what if this was 9t cubed plus 12t squared plus 4? Could you do it? No, because that doesn't break down. Could you do it if it was that? Because what would you do? You'd take out a t, and you'd be left with 9t squared plus 12t plus 4. Could we do that? Yes. Hatisha. You got, excellent question. If you were doing the no-name method here, which we just did, but it wasn't 9, 12, and 4, it was 18 plus 24 plus 8. What are you going to do first? GCF. Now, in this case, you have to keep the GCF. Yeah, the only time you don't keep the GCF is when you're actually doing your factoring, which is why I don't like it, because it goes against what you're used to seeing. Every other method makes perfect sense, yes? The no-name method is quick and easy, but if you don't know what you're doing, it can lead you astray. All right? But if you know what you're doing, it works very, 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 very well. Mr. Frick, what you got?
It doesn't. If you couldn't find any name for it, doesn't it make sense for you to coin a name here?
No, what would you call it?
Fake factor. The fake factor. That's a good name. I like that. Alliteration. It's got the actual thing in there, and it's got the word fake in it. And you don't like it, so it's like sort of the false.
False factor?
No, negative advertising. Yeah, false factor. Because it's like
Greatest common false factor? GCFF?
GCFF. GCFF sounds like a dangerous military. So yes.
Do what you will. Call it Kaboobly Hines. I don't care.
Yes, that is the official name. How do you spell it? Spell it?
That's how I'd spell Kaboobly Hines.
Oh, okay.
All right, is everybody good? All right. Finish page 83. Please notice there's some tricky McTrickletons at the bottom.